Hi everyone, in this video we're going to be talking about direct and inverse variation. This can be a skill that is difficult, but we're going to walk you through it and feel free to rewind and to look over these notes as we talk about this within the next few days. So today our essential question is, what is direct and inverse variation? So these are talking about different relationships that we see on a graph. And the first one that we're going to talk about is direct variation. So it's a specific relationship in which there is a constant ratio. Ratio means that we've kind of got a fraction going on. So a constant ratio, and we see this as y over x between two variables. This constant variation is variable k. That's the variable that we use to represent the constant variation. Direct variation equations are written in the form y equals kx, with that k being the constant. Okay, so this may seem like very foreign to you, and that's okay because we're going to walk through it. So, finding the constant k for direct variation, how we do that is by taking the y value and dividing it by the x value. So, if we take the y value 4 and divide it by the x value 1, then we're going to get 4. If we take the y value 8 and divide it by the x value 2, we're going to get 4. If we take the y value 12, divide it by the x value 3, we're going to get 4. If we take the y value 16 and divide it by the x value 4, we're going to get 4. So that means that our constant variation, our k, is 4. And how we would write our equation is y equals 4x. Okay, now let's look at a different example. So again, we're still taking the y value and we're going to divide it by the x value. When we do, we get negative 3. Take the y value, divide it by the x value, negative 3. Y value divided by the x value, negative 3. Y value divided by the x value, negative 3. Okay, so now our k for this one is negative 3, and how we would write this in our equation is y equals negative 3x. Okay, so now we're going to identify if the equations listed are direct variations based off of the way that they're written, the structure, and then if they are, we're going to identify what the constant is. So obviously, this first one is in the same format as the other two that we just wrote. So yes, this is direct variation, and our k is 3. Okay, let's take a look at the one to the right of this. So this is saying that our y-intercept would be negative 4. Whenever we have direct variation, our y-intercept is always going to be 0. It's always going to go through the origin. So, since this has the x minus 4, we shouldn't have anything after the x, then no, this is not direct variation. All right, now this one to the left and the bottom, we need y by itself, so we first need to divide by 2 on both sides. If you want to put a 1 in front of that x to be helpful, feel free to do so. So on the left side, we have y by itself. On the right side, we have x, and then the coefficient for the x is 1/2. And yes, this is direct variation, and our constant is 1/2. Okay, now let's look at the one to the right. We need to move a few things around, get y by itself, and then see if it's direct variation. So the first thing we would do is subtract 4x on both sides. So we'd have 2y equals negative 4x plus 6. Then we would divide by 2. And we would do that to everything on the right-hand side. So now we have y equals negative 2x plus 3. This 3 is telling us that the y-intercept is positive 3. So no, this is not direct variation, because for direct variation, the y-intercept is 0. It goes to the origin. Okay, so now we are on the second page, and this says to identify the graphs that represent a direct variation, and then if they do, then identify the constant. So this first one goes through the origin, so automatically we can say that yes, this is direct variation. Now we need to say what the constant is. And how we can do that is by finding the slope. Okay, so we're going to go up 3. So our rise is 3, positive 3, and our run is 2. So that is our slope. The second graph does not go through the origin, so nope, it's not direct variation, and we don't need to do anything else. Okay, in this next one, we are going to find the missing values of the ordered pairs. So we know that direct variation is y over x, and these are saying that they vary directly. So with our ordered pairs, we can say y over x equals y over x. So that's what we're going to do. So we have negative 4 as our y, and we have 2 as our x, and then we have y as our y, and negative 6 as our x. We're going to set these equal to one another. How we are going to solve is by cross multiplying. Okay, so I'm going to multiply the negative 4 and the negative 6. I'm going to get positive 24. And then I'm going to multiply the 2 and the y and get, oh, my bad, hold on, and get 2y. Okay, now we divide by 2, and we get y equals 12. So that was that missing value. Okay, we're going to do the same thing over here. So we're going to put our y over our x's and set them equal to one another. So 16 over 4 is equal to 24 over x. We are going to cross multiply. So we get 16x, and then we're going to cross multiply, and we are going to get 96. And then we're going to divide by 16, and when we do, we get x equals 6. So that was that missing value. All right, so now we've got a direct variation word problem. So this is the income of a computer analyst varies directly. So it's saying it varies directly, so we need to make sure that we use what we know about direct variation as the numbers of hours worked. If the analyst earns $256 for working 8 hours, find the constant of variation. Okay, so what we're going to do is since our income came first, we are going to set that as our y value. So income was listed first. It said income varies directly as the number of hours worked. So our y value is income. Our x value is our hours. Okay, so we know that with direct variation that our formula is either y equals kx, or another way that you could write this by getting k by itself is writing k equals y over x. So if we know y and if we know x, we know the values of them, then we can find our constant. So our y, So our income is $256 and our hours are 8. Okay, and when you divide those, you're going to get 32. So that is the constant. Okay, so now we're going to switch gears. So we just talked about direct variation, which is what you are super familiar with. That K represents the slope, whereas inverse variation is different. However, you can get the hang of it. So inverse variation is different. So an inverse variation is a specific relationship which there is a constant product, so multiplying, sorry, that's not very neat. So it like x times y between the two variables. This constant of variation is variable k, same thing. And then for inverse variation equations, the form that they are written in is y equals k over x. Okay, so we need to remember that. Meaning that in order to get k, we would need to do x times y. Okay, so we have some ordered pairs and we need to find the constant for these inverse variations. So we're going to multiply the x value times the y value. When we do, we get 20. We're going to multiply the x value times the y value. We notice that this is inverse variation because when you multiply the two values, you get the same number. Multiply the x value times the y value, and we get 20. So for this first example, our constant is 20. And we would write this in the equation, it would look like this. Y equals 20 over x. Okay, so this time, we're going to see what number we get when we multiply our x value and our y value. When we do, we get negative 12. Let's see if this varies inversely. If it does, we'll get negative 12. So we multiply these two. Yep, we get negative 12. We're going to multiply these two. Yep, we get negative 12. We're going to multiply these two. Yep, we get negative 12. So our k is negative 12. So our formula would be y equals negative 12 over x. So with direct variation, you would take the y and divide it by the x. And for all of the ordered pairs that you have, you would get the same number. Whereas with inverse variation, when you multiply the x value and when you multiply the y value, for each one, you're going to get the same number for each set of ordered pairs. We are not going to be graphing inverse variations. You will do that in one of your math classes in the future, but you will probably see in class what one looks like, but you don't need to worry about graphing it. So we're going to identify if these are inverse variations. So this first equation is, because it's set up in the right format, because remember our format is y equals k over x, and this one is, so yes, it's inverse variation. This one right here is direct variation, so no, this is not inverse variation. Our bottom left, if we were to divide by x on both sides, then we would get y equals negative 14 over x. So yes, this is inverse variation. And guys, we should have been labeling the constants. So for the first one, the constant is 50. For this one, the constant is negative 14. All right, and then this last one, let's multiply by x on both sides to get y by itself. When we do, we get negative 6x. Nope, this isn't inverse. This is actually direct. So nope. Okay. Now we're going to find the missing values of the ordered pairs that vary inversely. For inverse variation, we multiply our x and our y. So we're going to set them up and solve. So 12 times 14 and 24 times y. 12 times 14 is 168. Negative 24y on the right-hand side, we divide by negative 24. So our y is negative 7. All right, now let's do this one. So we have 9y and we have negative 18 times 6. Negative 18 times 6 is negative 108. If we divide by 9, then we get y equals negative 12. So that was our missing value. All right, last one. So here's a word problem. The time it takes to bake a turkey varies inversely, and we know that the first variable that is mentioned, so the first measurement that is mentioned is our y value. So time is our y value. It varies inversely with the oven temperature. Okay, so our x value is our temp, or temperature. If it takes 3 hours to bake a turkey at 300 degrees, find the constant of variation. Okay, so we know that our formula for inverse variation is y equals k over x. If we're just solving for k, then all we need to do is x times y. Okay, so our x value, our temperature is 300. Our time is 3 hours. So our constant is 900. All right, good job, guys. This is a tough skill. We will go over it more, but good for you for watching the video and taking notes. Have a great day.